Dr. Mario Kratz, welcome to the show.
Thanks so much, Ty. Wonderful to be here.
So you transitioned from over 25 years in academic research to start Nourished by Science, which, by the way, is a great channel for anyone who hasn't checked it out. Nourished by Science on YouTube. Highly recommended. Can you tell us, about your time in academia and why did you decide to make that switch?
I got my PhD in Germany 30 years ago. And then came for a postdoc to the United States, initially planned to be here for a year. And then realized that this is just an amazing research environment for doing the type of nutrition work that I'm really passionate about, right? Where, as I'm sure we're going to talk about later, a lot of nutrition research is based on observational studies that in some ways are limited in the strength of conclusions that we can draw. And so I was really eager to conduct really well-controlled, randomized controlled trials where, we can control the exposure, what people eat, and then also really deeply phenotype people. And I saw that the United States are really offer an amazing environment for this. And specifically at the time, I did my postdoc at the University of Washington in the lab of Dr. Scott Weigel. The University of Washington was one of the few centers that had a general clinical research center. I'm not sure if you actually know these still, the GCRCs. They were an amazing resource. They were funded by the National Institutes of Health, where basically an entire hospital unit was funded by the NIH with the rooms was paid for, the staff, and a researcher could come in with a proposal and say, all right, I would like to, control what people eat in this and this fashion. And there would be dietitians and they would do the calculations and they would prepare the food. And you could actually do a really well-controlled feeding trial for whatever period of time was necessary. So I actually, during my postdoc with Dr. Weigel at the University of Washington, used the GCRC at the UW to run a 16-week randomized controlled trial. And so this is, really a comprehensive 2.5-year effort where we enrolled, I actually forget how many people we enrolled, 70 or something like that. 70 people, randomized them to 3 arms, 16 weeks on a controlled diet each, where we really knew every morsel that went in and out of their bodies. And we had to pay for almost none of it. We had to pay for the food. We had to pay to analyze the lab samples. But other than that, it was all covered by the GCRC grant by the NIH. And I felt like, oh my God, what an amazing resource this is. And this was really the time when a lot of this type of really well-controlled dietary randomized controlled trial work was conducted in the United States. And so I applied for faculty positions and actually was very lucky to find one at the Fred Hutch Cancer Center, also in Seattle, just down the road from the University of Washington. And I was able to continue using the GCRC, but Fred Hutch also had its own facility that was somewhat similar. And so I basically felt like this is a fantastic setup for me to do this work, to really supplement, all the other types of work we do in nutrition, to also do very well-controlled, randomized controlled trials where we control very well what people eat and then also measure deeply how that food affects their metabolism, their lipids, how much they eat, all of those questions, right, that are highly relevant. And, I was very sorry to see that roughly when I was hired, the financial crisis hit, and roughly around that same time, I forget the exact timing, NIH decided to do away with the GCRC model. And they entirely changed it such that now an investigator would have to go to the clinic unit. The clinic unit still existed, but now you would have to basically pay for every little thing that was done for you. Right? So you would have to get, say, an R01 from the NIH, a large research grant, and then pay for the nurse who draws your blood, and pay for the room that your research participant is seen in, and pay for the dietitian who calculates your diet, and pay for the, person who hands the food over to the participant. And suddenly, and I actually still know these numbers. So when I did my my controlled feeding study with Dr. Weigel, we paid about $12 to $13 a day for a controlled research diet. And that shot up to about $120 or so a day. So we had roughly a tenfold increase in cost. Plus now also all the clinical procedures had to be paid for. And so what I found myself in is a situation where, as a young faculty member, I was trying to do ambitious work, to really answer some pressing questions that I still saw out there. And I just couldn't fit them into any kind of grant because, as many people know who work in biomedical research, the amount of money that's allowable in the standard R01 grant, for example, hasn't really been increased in quite a long time. And as a result, now we're trying to fit in ever-increasing salaries for faculty and staff. We're trying to put in all the increasing costs for this type of research. And so every single time when I was writing a grant, I was stuck between a rock and a hard place, being either, studying small groups of people and studying them well and deeply, and then being open to the criticism that, well, this is too small a study. It's not going to have the statistical power to actually answer the question. Or, studying more people, but not controlling the diet nearly as well, or not phenotyping outcomes, what happens to people's health outcomes nearly as well. And then the critiques by the reviewers would be, well, that's a nice big study, but there's lack of control over the diet. Or why are they not also doing a clamp study to measure insulin sensitivity? Or why are they not also doing an MRI scan to measure liver fat? And all of these are justified critiques, because what we really need in nutrition these days, in my opinion, is large randomized controlled trials that are adequately powered, that control the exposure, the diet very well for a sufficiently long period of time, and that also include really deep phenotyping, not just maybe one blood draw and a measurement of body weight, but ideally actually do include an MRI scan to look at visceral fat and liver fat, that do include an OGTT to look at glucose tolerance and a clamp to look at insulin sensitivity. And these studies are quite expensive and just not fundable. And basically I tried to make it work. For many years, I did get grants, some small ones, mostly a couple larger ones. But really, I think the gist of it is that my entire group, including me, felt that the work we were really burning to do, that we felt would really answer some pressing questions, went nowhere because it always had some limitation that would make it too easy to be shot down. And so I basically decided I don't want to keep working for the garbage bins, right? Because writing grants is a lot of work. In the end, you're not getting it funded. Well, you can do it once over or twice, but in the end, it lands in a garbage bin. And you've basically done all this work, including sometimes 2-year pilot studies, for nothing. And so I decided that even though there are still questions that need answers, and I'm really still passionate about this, so I really feel we need to change something about how we do research, specifically in the United States, because it has been a pretty substantial turn for the worse in the last 30 years or so because of this change in research infrastructure. But I decided for my own life, my own career, I wanted to rather devote my my knowledge and my expertise in obesity, in cardiovascular, in metabolic disease, to actually sharing what we already know with people who are motivated to live a healthy life. And that was partly motivated by this trend on social media, specifically on YouTube, but also on other social media platforms, that a lot of people sharing information about nutrition, health, longevity, let's just say they have ulterior motives. Either they're part of a dietary tribe where they may not, be too serious about sticking to dietary to scientific evidence, and instead they have some kind of dogma that they like to share, or there is financial conflicts of interests. People who talk about the powder simply because they have an affiliate link for that powder, or they talk about supplements because they manufacture these supplements themselves. And so my goal from the start was to create a channel that's purely based on evidence, and not just, evidence defined as I cite one paper, but ideally looking at the cumulative evidence on every issue I talk about, meaning all the available research, and doing so in a way that is free of financial conflicts of interests. So I don't do any speaking engagements for pharmaceutical or food or supplement companies. I don't do affiliate marketing. I don't do sponsored posts. And now that you're starting your own YouTube channel, congratulations, you'll see very quickly that once you have a few thousand subscribers, you'll be flooded with quite lucrative requests for people who want to sponsor your stuff or, do some affiliate marketing with you. And I'm sure, people have to make a living. So I don't want to say I want to criticize everyone for doing this. I think there are ways of doing this that's fine, but I've decided I really want to try something else and try to do this in a way where the viewers can trust that all of my content is really entirely free of this type of conflict of interest.
Yeah. Wow. It's so great that you decided to pursue that, because very quickly when you started your YouTube channel, you had a lot of interest, and some of your videos I think have over 2 million views, which is pretty surprising and shows that there's an appetite for genuine, unbiased information on nutrition, even in longer form content, right? So I think people really crave this type of information. So we'll dig into this now. And it's one of the reasons I wanted to have you on, is that you have, you're pretty free. Everyone has some bias, but you're pretty free of conflicts of interest. You have a pretty well-rounded approach and perspective. And so we're just going to go through some of the key areas in nutrition and provide people with an overview of what is the evidence and how can we look at this objectively. So, specifically around cardiometabolic health, you have a lot of expertise in this area from your research and from now reviewing the literature and creating this content. So, specifically, how do you prevent chronic disease through diet and lifestyle? And to start, can we just give a quick primer of what metabolic health is for those who don't know, and why does it matter?
Yeah, I think everyone defines metabolic health a little bit differently, right? Because it's not really that precisely defined. The way I define it is, our metabolism is all of the molecules, substances, basically floating around in us, many of which are regulated in some way or another. And so I would say metabolic health is that everything works the way it's supposed to work. And we can take a few very specific examples for this. So very often we talk about metabolic health, we talk about things like glucose metabolism. And glucose, blood glucose, is, a sugar. The sugar glucose is the most common sugar in our blood. There are actually some other monosaccharides or sugars circulating in the blood. We could talk about that too if you want to, but the main one we pay attention to is glucose. And glucose is what we call homeostatically regulated. So what that means is that our glucose level in the fasting state, when we haven't eaten, always should be between 70 milligrams per deciliter and 100 milligrams per deciliter. And so when it drops below 70, there's a response by our body that increases the glucose and brings it back up into this range. And if it goes above 100, there's another response, and it's being driven back down. And the same actually happens when we eat. So when we eat, the glucose level, the body is unable to keep it in that very narrow range, but most of the research suggests that the range the body tries to keep it in even after a meal is between 70 and 140 milligrams per deciliter. For those of you in England and other countries, this is 3.9 to 7.8 millimoles per liter. So that's the normal range that basically people's blood glucose levels should be in about 98% or so of the time if they're healthy. And so what that means is that even if you eat a very large amount of glucose in the form of actual glucose or in the form of starch, which is just chains of glucose, so that would be potatoes or rice or pasta, right? You eat these, they're digested, the chains of glucose are digested, and the glucose is absorbed. And so then the glucose enters your blood, and that raises your blood glucose level. And then the body has to deal with that by taking the glucose up into cells after a meal. That's mostly the musculature, but to smaller degrees also the liver and the fat tissue. And that's an amazing, amazing feat, actually, that I think most people never think about. Because when you think about how much glucose we have in our blood, so let's just for simplicity's sake, think about fasting state, we have about 100 milligrams per deciliter glucose in our blood. A deciliter of blood is 100 milliliters. An adult man may have something like, let's say, 6 liters, 7 liters of blood. So that's like 70 times 100 milligrams. That's about 7 grams of glucose in all of our blood, right? So let's just imagine we took all of my blood. Not a nice thought, maybe, but stick with me for the thought experiment. It's like actually a little bucket. And the amount of glucose we have in it is just about a teaspoon and a half. It's very little, right, in the fasting state. And so I asked my daughter this question once. Well, what happens now if I drink a can of Coke that has, say, 12 teaspoons of sugar in it? What happens to the amount of sugar in all of my blood? And she said, well, if there's 1 in there in the fasting state and you drink a Coke that has 12, then there's going to be 13, right, teaspoons. And you would think that, right? But that's not the case, because even in the postprandial state, and even if you just drink down the Coke very quickly, in a healthy person, the amount of glucose in all your blood never rises above maybe 2.5 teaspoons, right? So it's pretty substantial ability of the body to just sense the glucose coming in very finely and very early, actually. Also very fascinating topic about when the body already responds to changes in blood glucose. And basically these very fine-tuned responses that allow us to have our blood glucose in this very, very narrow range, as I said, from 70 to 140, right? That's a twofold range. Even though we can sometimes not eat any carbs for weeks or months, or we can, in any meal, eat 150 grams of carbs, right? Mm-hmm. And I personally think that's just amazing. And the fact that this works so well is just an illustration of the fact that there must be good reasons for it, right? And so if this doesn't go well and our blood glucose even slightly gets out of this range, right? So even in someone with manifest diabetes where the fasting level is maybe already 150 and it goes to 300 and stays there for a while, let me emphasize that is still actually a very good regulation. Because if it wasn't regulated at all and you drank that Coke, your blood glucose would go to 500 or 600 or 700, right? And so, the fact that this is so tightly regulated, as I was saying, is indicative of the fact that elevated blood glucose levels are just not a very good thing. And we know that for sure that, even these slight deviations from the optimal do tend to be associated with an increased risk of a number of chronic diseases, including atherosclerotic cardiovascular diseases like heart attacks or strokes, chronic kidney disease, certain types of cancer almost certainly qualify here. And so it's pretty fascinating. But you asked initially about metabolic health, and I think whereas many people talk about blood glucose exclusively, I'd actually say there's a whole bunch of other things that we should also maybe consider when we talk about metabolic health. And that is basically the entirety of, the metabolites and how they're working together in our body. In some ways not as strictly regulated, in other ways fairly strictly regulated as well. But that's would be my definition.
Okay. So in general, most people kind of view the metabolic health term as something related to sort of the blood sugar regulation, but it also can be much more broadly interpreted as any sort of process that is related to metabolism. So basically all of the food that we eat and how we metabolize it.
Right, exactly. That's how I would say it.
Okay. So some of the specific markers now, what are we looking for if you're going to your doctor? What type of lab test is going to tell you about your metabolic health? What should you discuss? What should you be looking out for?
Yeah, that's a good question. So maybe let's start with blood sugar regulation. So what the doctor will automatically do, you don't even have to ask for this, is get a fasting glucose. And that's a good measure because it tells you whether your body succeeds in keeping blood glucose levels in that normal range between 70 and 100 in the fasting state, right? If that's already not the case, that can already be indicative of trouble. Trouble meaning some degree of glucose intolerance, right? Glucose intolerance being a term that describes that our body has lost its ability to perfectly regulate blood glucose within the desired range. Second measure that the doctor will get is HbA1c or A1c, as it's sometimes called. So that's a measurement of the degree to which glucose has attached itself to the hemoglobin molecule inside the red blood cells. And that's actually an interesting process, because one mechanism through which chronically elevated blood glucose levels are thought to be harmful to health is that the glucose attaches itself to proteins and actually changes their function. And so this attachment of glucose to the hemoglobin molecule is basically a direct measurement of the degree to which this happens, and it's directly correlated to the average blood glucose concentration over the last 3 to 4 months. And this is related to the average lifespan of a red blood cell. And so if your HbA1c is in a normal range and your fasting glucose is in a normal range, that would suggest that you have normal glucose tolerance. But I'd say suggest, because there are limitations actually to some of these measurements. So HbA1c, let me start with that, because this is something I think that's not sufficiently known, that there are a number of conditions in which, for example, the lifespan of the red blood cells is changed. For example, in someone who has anemia. There's also some genetic conditions. And if that's the case, then your HbA1c could be just substantially reduced or elevated falsely. In other words, your HbA1c may be in the pre-diabetic range. I know personally of dozens of people who have, elevated levels in the pre-diabetic range. And, it may very well be that to some degree, they don't actually have elevated blood glucose levels throughout the day, but that they have differences in how long the red blood cells live and how long the hemoglobin molecule in those red blood cells is exposed to the glucose in the blood. So it basically then appears as if the blood glucose level had been higher than it actually has been. So personally, I do think, and there's some good evidence, actually, some papers that have looked into this, specifically in the pre-diabetic range. There is somewhat of a risk of a false high HbA1c, meaning you have an HbA1c that's in the pre-diabetic range, suggesting you have some degree of glucose intolerance and chronically elevated blood glucose levels, where in reality that's not the case. And that's fairly well documented. So I'd say people should measure HbA1c regularly, track it. If it changes, it's certainly meaningful. But also be somewhat skeptical if it deviates from the norm, and ask questions, like have some discussions with the doctor about follow-up testing specifically. And that, I think, routinely by good doctors, this is done. I think no doctor would just have a diagnosis for, say, diabetes based just on the HbA1c. So if someone has deviations in their HbA1c from the norm, it would certainly make sense to also do a clinical oral glucose tolerance test, where you actually measure your response to a standardized load of glucose and you see how your body reacts. Clinically, usually the way this is done is that the doctor draws blood, measures your blood glucose, gives you a drink that has 75 grams of glucose, and then after 2 hours, the glucose level in blood is measured again. And then based on whether or not you're below or above a certain threshold, you're basically diagnosed to have normal glucose tolerance, pre-diabetes, or diabetes. Now, that's a good clinical test, but I'd say we can get a lot more information from this if we add maybe one time point. So if you can convince your doctor to also get, say, some blood drawn at the 1 hour time point, and ideally also include insulin in these blood measurements, you get a lot more information about what's actually going on with your blood sugar regulation and your insulin sensitivity in this context. But I'd say that's definitely a good follow-up for people where there is suspected glucose intolerance.
Okay, now, so you kind of start with, if I can understand this, you start with sort of this, the first test is this fasting glucose. Mm-hmm. It's quick. Most doctors could order that. You may get a hemoglobin A1c, which is, if I understand correctly, more about your long-term blood sugar regulation. And then what you're saying is you can get a oral glucose tolerance test to have more definitive answer, and even multiple time points, so you can see how you handle that over time. Is that right?
Yeah. And I'm suggesting the multiple time points because, sometimes when you just look at the 2-hour time point, maybe there you have 135 milligrams per deciliter. If the doctor just looks at the table, he or she would say, well, this is normal glucose tolerance, nothing to worry about. But maybe if you have the data from a 1-hour time point and you see it's 250 then, that's way too high. It should probably never be like that high. Then you get a sense of, oh, well, maybe clinically speaking, I'm still fully normal, but this is probably no longer optimal. And in that regard, I think it can be quite informative to have that additional time point if you can convince your doctor to include that.
Yeah. Okay.
Now, there's another test that I very, very strongly recommend people get regularly, and that is a fasting insulin in addition to fasting glucose. And you can use the fasting insulin and fasting glucose together to calculate a measure of insulin sensitivity and also to come up with an estimate of your beta cell function, so the ability of your pancreatic beta cells to produce insulin. And this is really, I think, a very much underappreciated biomarker clinically, simply because whether or not we're glucose tolerant is a measure of whether our pancreatic beta cells can make enough insulin relative to our degree of insulin sensitivity. So what that really means is wherever we are in terms of our insulin sensitivity. Now the question is, can our beta cells make enough insulin for that level of insulin sensitivity, right? If we become insulin resistant, now we need more insulin. And so the question is always, where do we stand in terms of our level of insulin resistance and our degree to which we're able to make enough insulin for that level of insulin resistance or insulin sensitivity. So
can I ask then, is it possible to have your blood glucose looks normal, but there's a problem with insulin and insulin resistance that's beginning to take place, but if you don't measure your insulin, you never find that out until maybe much further down the line?
Very much so. And that's an excellent question. So maybe what people need to understand is, what insulin does mostly is after a meal, when we eat carbohydrates, our blood glucose level starts to rise and our pancreatic beta cells secrete insulin. And that secretion actually happens in 2 stages. Potentially, we're going to come back to that later. There's basically some insulin that's being secreted very early on in the meal in the so-called first phase insulin response. And that happens, and that's just a scientific curiosity for those of you who like this kind of stuff. This happens already, or starts to happen already, when we sense food that our body has learned leads to an increase in blood glucose. So in other words, the body doesn't even wait until we have ingested the carbs. It definitely starts when we're chewing the carb-rich food, but there's a small part of it that also already starts when we, for example, seeing the bread, or we're smelling the toasted bread. And the body knows, well, in the past, when that has happened, 10 minutes later, the blood glucose has gone up. It already starts to prepare and secrete a little bit of insulin there.
Wow. So what about thinking about the food?
Probably a little bit as well, I would think. I mean, the question is, when the thinking about the food in the past has led to blood glucose rising because you've then gone immediately to the kitchen and get some food, it probably also can trigger this little secretion of insulin by the beta cells. It's really fascinating. How well this is regulated. And I'm explaining this in some detail because this first phase insulin response, so insulin secretion by the pancreas in the first 10 minutes or so, is extremely crucial for blood glucose regulation. But that aside, in general, insulin is being secreted and then it acts on the liver to stop producing insulin, because in the fasting state, the liver releases a little trickle of glucose to keep blood glucose in that 70 to 140 milligram per deciliter range, as other tissues take up glucose regularly, right? So you can imagine, Atai, as you're sleeping or maybe you're fasting throughout the day, you're still thinking, right? Your brain is still active and it continues to take up glucose from the blood to make fuel, to make energy. And so that glucose that is disappearing from the blood needs to be replenished. And so the liver basically releases a little trickle of glucose while you're not eating anything. Now, after a meal now, we have a lot of glucose coming in from the gastrointestinal tract. And what that leads to then is insulin is being secreted, goes to the liver, and switches off that release of glucose by the liver. And then in the muscle cells and the fat cells, it binds to those cells and basically leads these cells to open the door to glucose. Specifically what it does is it moves a little glucose transporter to the surface of the muscle cell specifically, and then glucose from the blood can enter through that glucose transporter into the muscle cells. And so that way then the glucose levels that are starting to rise from all the glucose that is coming in from the gastrointestinal tract, from the meal that we just ate, is basically starting to disappear into the muscle cells and to some degree also into the fat cells for storage. And that can bring glucose levels back down then into the normal range. So that's in general how this works. Now, you were asking about insulin resistance. And I'm sure we can talk about causes of insulin resistance later, but as a general, to kind of illustrate what generally this means, if you think in an insulin-sensitive person, you'll need a certain amount of insulin to do this job, right? Let's say you eat a bowl of rice and you need a certain amount of insulin to help the body deal with the glucose from that rice and have that all taken up into muscle and fat cells. Now, if someone becomes insulin resistant, that means the muscle cells, potentially the fat cells, potentially liver cells, are less sensitive to that insulin. So when the insulin comes along and binds to the insulin receptor on the surface of these cells, the cells to some degree respond to it, but less strongly so. And so now you need more insulin to do the same job. And you may need, say, in an insulin-resistant person, 2 times, 3 times, maybe 10 times, maybe 20 times more insulin after a meal to help the body deal with this amount of carbs in, say, a bowl of rice. And so for that reason, the body, because as I've explained earlier, it's really bad when the blood glucose level rises and chronically stays high. So the body really tries to keep blood glucose in the normal range. So if there's insulin resistance, the pancreas will try to produce more insulin so that the blood glucose level can stay in that normal range. But as you can probably imagine, if now after every meal you are consuming, say, bread or rice or pasta, right? Starchy vegetables, whatever it is, your blood glucose levels rises a lot because there's 50 or 80 or 100 grams of carbs coming into your body. And you need huge amounts of insulin to deal with that, right? First of all, that's already a risk factor for chronic disease, as we know, like insulin resistance by itself. But also many of the things that can cause insulin resistance are risk factors for chronic disease. So this is definitely worth knowing all in and of himself. Like there's worth in understanding whether your insulin resistance as a risk factor for chronic disease. But there's also value in knowing about insulin resistance because it's basically the early stages of what in many people eventually becomes glucose intolerance, leading to prediabetes and diabetes. And that is because if there is something in your body that is undetected because you don't know about it, that makes you insulin resistant, right? Maybe initially your pancreatic beta cells can keep up with that and compensate for it by making more insulin. And then because it's still not diagnosed, it continues. You become more insulin resistant and the beta cells keep making more insulin and you become more insulin resistant. And now the beta cells cannot make more insulin, right? So we have a state now where we're insulin resistant and we have some degree of beta cell dysfunction. Even though we can potentially make a lot of insulin, it's not enough. And so now we have high insulin levels, but they're relative to our degree of insulin sensitivity, they're too low. And so now we after every meal, we have these very high insulin levels and also on top of that, very high glucose levels. And that's a really, really bad combination because, again, both high insulin levels and high glucose levels are risk factors for chronic disease. And actually, in modern life, this is a situation we have in probably, I would say, hundreds of millions of people worldwide, where we have some degree of either isolated insulin resistance with still good glucose tolerance, and people don't even know about it, I'd say that's a disaster because, that they're exposed to this insulin resistance sometimes for decades and don't know about it. Or we have some combination of insulin resistance with some degree of glucose intolerance where now people have pre-diabetes or diabetes. And that's a combination of several different risk factors that dramatically increases their risk, as I said, for atherosclerotic cardiovascular diseases like heart attacks or strokes, kidney disease, certain types of cancer. And the cancer link specifically is maybe worth emphasizing a little bit more here because insulin doesn't just have functions helping the body deal with glucose. Insulin is also a very potent growth factor. And so if you imagine now, all of us constantly have cancer cells in our body. And the question for each individual cancer cell is, well, there's forces that are trying to fight the cancer cells, like our immune system potentially, right? And there are forces that are helping the cancer cells. And the growth factor or fuel that the cancer cell wants, like glucose in abundance, would be things that help the cancer cell. And so for each cancer cell, it's like this balance between factors that fight it and favor it, right? And so the way I see it is if we're insulin resistant and we have chronic hyperinsulinemia, and particularly if that also comes with hyperglycemia, high blood glucose levels chronically or after meals, then we're tipping the scales a little bit more in favor of helping the cancer cells, right? And so over many years to decades, that is very likely to be one reason why people, for example, who carry certain types of body fat more, that makes them insulin resistant and potentially glucose intolerant, why they have a very substantially increased risk for any number of chronic of cancers. Sorry.
I mean, you're making me want to go get my insulin checked right now. So maybe I'll schedule that appointment with my doctor after the meeting.
I have to say, personally, I think a fasting insulin is, to me, one of the least utilized and most useful measures because, and this may become more clear when we talk about the causes of insulin resistance. So as I've hopefully explained to everyone, insulin resistance and hyperinsulinemia in and of themselves are a major risk factor for chronic disease. But now when we think about, okay, why are people insulin resistant? There's a number of different things we could highlight, but let's just pick a few. We know that if people accumulate excess body fat, and specifically fat inside of the abdominal cavity, what we call intra-abdominal fat or visceral fat, so that's fat surrounding the inner organs, and particularly fat inside of the inner organs and the musculature. That's what we call ectopic fat. Right? So we have accumulation of fat in, say, muscle, liver, pancreas, right? These are all tissues that are not at all designed to store fat. But we know this happens sometimes in people once they accumulate enough body fat. So if you have too much visceral and ectopic fat, that tends to be a situation where people, to some degree or another, become insulin resistant. Another exposure that could make you insulin resistant is inflammation. So if you have a low-grade chronic inflammation, maybe a hidden one, maybe you have an autoimmune disease you don't know about, that could actually contribute to you being insulin resistant. Another is chronic stress. Stress is one of those very potent acute inducers of insulin resistance. Another one is, say, low muscle mass or a very sedentary lifestyle. So there's basically a whole bunch of different things. There's a whole bunch of medications, medical conditions, thyroid disease, sleep apnea. They can all cause insulin resistance. And so if clinically we were to measure fasting insulin and fasting glucose together to calculate this measure of insulin resistance, and for anyone who wants to do this, it's called HOMA-IR. There's other versions of it, but HOMA-IR is a pretty good one, and you should be able to find online calculators for this. Then if you're fully insulin sensitive, right, then you can rest assured in a few things. You can know, okay, my insulin sensitivity, at least based on this estimate that's in fasting blood, is fairly good. And it's also likely that you don't have any of those major causes of insulin resistance. Otherwise, your insulin sensitivity wouldn't be so good, right? And if you're insulin resistant to some degree, it gives you an opportunity to ask, okay, well, why is that now? And then you can look, well, could I have excess body fat? Maybe hidden body fat in my visceral depots, intra-abdominal depots, or ectopic depots. Could I have maybe sleep apnea and don't know about it? Or maybe I have a hidden inflammatory disease. Like, it can lead to further digging and understanding and ultimately addressing whatever the issue is, rather than ignoring it potentially for years or decades. And then at some point you'll get the diagnosis, okay, now you have diabetes. And even then, often we're not asking whether we're insulin resistant and what the issues are, but we're giving a pill, right? We're saying, okay, well, take some metformin and then it's going to be fine again for a few years. But we've never addressed actually the underlying issues. And I really think that's a big thing that we can do for ourselves, that we just advocate, go to the doctor and say, I'd like to get fasting glucose measured. I'd like to get fasting insulin measured. I'll go home with these data. I'll calculate my HOMA-IR. And I'll do this every couple years, 3 years. And when it trends in the wrong direction, where maybe I'm in my 20s and it's 1 or 1.2 or 1.3, that's all fine. None of the small, these measurements are somewhat variable. So, don't sweat the small stuff too much. Like, there's really no difference between a HOMA-IR of 1.2 and 0.8, something like that. That's all normal. But once it starts to go into like 1.8, suddenly it's 2.3, 2.7. Well, now you should really say, well, what's going on now, right? And then ask questions. Okay, am I insulin resistant? And if so, why? And look at some of those potential causes of insulin resistance. And your long-term chronic disease risk could be substantially reduced if you manage to identify what it is that makes you insulin resistant and address it, right? So if you learn, oh, I do have actually a fatty liver, and I do have sleep apnea, and you get these things treated, you lose some weight, you wear your CPAP machine, maybe you have been too sedentary, you start a resistance training and exercise regime, you go for a walk every day. Suddenly, your health trajectory is basically an entirely different one. And I really believe that we're missing out in a major way by not focusing more on assessing insulin resistance, at least in the fasting state. And let me just say this as the final disclaimer. HOMA-IR is not the gold standard measurement of insulin resistance. So in a clinical trial, we always would do more sophisticated measurements where, it would take a few hours, several blood draws, and then complicated calculations. What we can say is HOMA-IR is correlated fairly well with these gold standard measurements, but it's not perfect. There are ways in which it can be somewhat incorrect. And one specifically is maybe worth pointing out, because it affects a lot of people nowadays. And that is, if you're very sedentary and you have low muscle mass, that in and of itself could give you kind of a form of insulin resistance, simply because you don't have enough tissue that the glucose can be taken up into after a meal. But it doesn't necessarily show up in the fasting state, because, as I've explained earlier, in the fasting state, the main organ that regulates your blood glucose level is the liver, right? The liver releasing a trickle of glucose. The muscle isn't really active in the fasting state. And because fasting insulin and fasting glucose are in a fasting state, you're not really able to measure this specific muscle-related insulin resistance. So, definitely worth knowing about these types of relationships and limitations as well.
It's so, it's kind of baffling how people could go years or even decades with this sort of insulin resistance without even knowing it's there, right? I mean, it's just such a missed opportunity, and it's so important to measure not just fasting glucose, but fasting insulin. If you haven't done that, please consider doing that. There's all sorts of diet and lifestyle stuff we can talk about, but if you don't know that's going on, it could just be harming your health and increasing your risk of cancer, obviously other cardiometabolic diseases, and ultimately death. So super important. And I think one other aspect of this, when you start talking about optimal levels, not just sort of what are the thresholds that will classify you into something, some sort of public health recommendation, we hear a lot of talk these days about continuous glucose monitors, or these CGMs, right? This is also very controversial, because you have people who are saying it's all about you need to measure your glucose throughout the day. You're adjusting. If you have this type of food and you realize it spikes, then you're trying to not eat that and you're going to eat something else. There's a bunch of potential problems with that. Can you tell us a little bit about these CGMs and what are the pros and cons? How do we think of these in a balanced way?
Yeah. So I'd say this, for full disclosure for everyone, I think if you asked 100 scientists working in this field, diabetes doctors and so forth, there would be at least a 50-50 split in terms of people saying, well, these are totally useless, at least for people who don't have any blood sugar issues. Like healthy people should never use CGMs. There's certainly a good number of experts and colleagues who say that. My position is that I think if we know how to interpret them and understand their limitations, they can be useful, including occasionally for people without blood sugar issues. I've made a couple of videos about this, and I'm pretty passionate about people understanding how to properly interpret this. So number one, maybe I would say, is if you get your CGM, do not obsess over every little up and down in your numbers. I think, as I've just explained, being chronically stressed in and of itself makes you insulin resistant. And that's not a good thing. You can actually just worry yourself. You can worry your blood glucose levels up. Like if you worry enough, your blood glucose levels will rise because you become so insulin resistant, your pancreas may not be able to make enough insulin. No one's ever gotten healthier by worrying excessively about every little thing. So here, I'd say take a bit of a chill pill with your CGM is what I would suggest. Have some intellectual curiosity about it. You'll eat your sourdough bread with your avocado and see it go up, and you're like, oh, interesting. And next time you'll eat, and you'll just have this type of curious attitude. And really look at the long-term patterns. Like, don't look at any one meal and just obsess over it and be like, oh my God, like I've seen these videos of influencers, and they have hundreds of thousands of views on these videos where this woman was eating like 5 bell peppers, right? And she was looking like in life, like she was looking during the video, she was looking at the phone like, oh my God, it's going up, like 120, like, oh my God, it's 125 milligrams per deciliter. And she swore at the end of the video never to eat bell peppers again. They're toxic to her body. And, there's so much wrong with this picture, right? Because
you got to go full carnivore so you don't get any.
Yeah, I mean, first of all,
spikes.
The type of blood sugar spike that she described there, and maybe that's my next topic, wasn't really a spike, right? As I've explained earlier, the data are fairly clear that in normal, healthy, glucose-tolerant populations, our blood glucose level is kept in the 70 to 140 milligrams per deciliter range about 98% of the time. But even in fully healthy people, sometimes it goes slightly above or slightly below. I found it in healthy people, it never goes above 180 or so milligrams per deciliter. So if it does go above 180, that's what I would actually consider a spike. But what that means is, let's say a healthy person who has normal glucose tolerance, let's say your fasting blood glucose is 90 milligrams per deciliter, right? You'll have 90 milligrams per deciliter to go until I personally would call it a spike, right? If with every meal it goes to almost 180, that's probably still not ideal. But if it goes to 130, 140, 150, comes back down, and within about 2 hours it's back to your normal, that I would consider consistent with normal glucose tolerance. And so that's actually, if we look at just large groups of even young 20 to 25-year-old athletes, that's what their blood glucose responses look like. Now, in the light of this, I find it very concerning that there are a number of influencers out there whose entire business model, let's say, seems to be based on making an increase in blood sugar by as little as, say, 30 milligrams per deciliter seem problematic. And there's a couple specifically of influencers I know who basically say that anytime it increases from your baseline by 30, it is a spike. It's an undesirable and not physiological spike that should be avoided. And I really, really strongly disagree with that, simply because increases by 30 or even 40 or 50 milligrams per deciliter are routinely seen in the healthiest people on the planet after meals, right? So why we're basically telling healthy people that if they eat, a sandwich and their blood glucose rises by 40, that is a problem, is, I think, a problem in of itself, because then those people who really have nothing to worry about, they obsess over their blood sugar response and they think something's wrong with them, right? And they go through all these means to try. They say, okay, I'm not going to have the bell peppers. I'm not going to have the sandwich, right? And so now you're starting to make decisions based on what I would call an imagined worry, right? So I really strongly suggest not doing that, right? So what do I suggest is, if you wear a CGM, look at the broad pattern. Try to understand how you respond to certain foods. Like certainly if you are glucose intolerant, you have diabetes or pre-diabetes, and you see that maybe you've always had oatmeal for breakfast, but your blood sugar level rises to 280 after eating your oatmeal, or 240. Well, maybe in that case, I would say that is a source, a reason for you to worry, because that's too much, right? I'd say if it goes clearly above, say, 180, even occasionally, I would try to do something about that. And if it regularly goes up above 140 and stays there for long, I would also pay attention to that. These are all signs of glucose intolerance. And I'd say the first step in those cases should be to try to limit or eliminate those foods that give you these rises. But then also in a second step, and I think that's my biggest recommendation, to also ask, okay, well, this tells me I'm glucose intolerant, because this shouldn't be happening no matter what I eat. So why is that? Why am I glucose intolerant? Get a fasting insulin, a fasting glucose, try to understand whether you're insulin resistant. And if you're insulin resistant, try to understand, why you may be insulin resistant, and then really address that from the bottom up. Try to find the root cause of what's going on with your glucose intolerance and address that, right? Rather than just using the CGM to minimize your blood sugar response, which inevitably will lead you to a low carb or even carnivore diet, because your blood sugar will look the best on a very low carb diet. Mm-hmm. But that's only because we don't have a continuous fat monitor, right? If we had a continuous fat monitor, suddenly rice would look great and your steak would look terrible. So I think we have to be, as I've said before, get the CGM with a chill pill and a good dose of perspective that, yes, we're focusing on one biomarker, it's an interesting one, but do not start making all of your health decisions just based on little ups and downs in blood glucose, particularly if they're fairly normal and your blood glucose mostly is in a normal range.
Yeah, we shouldn't get tunnel vision.
Exactly.
We really shouldn't over prioritize. I think it's important, but it's not the only thing that matters. I'm really curious to know about triglycerides. Do you have any sort of assessment that you include? Like, do you look at triglycerides? Because I know, in my own diet, when I've sort of assessed my lipids, including triglycerides, when I'm on a lower carb diet, my triglycerides are generally lower. And when I've been on a higher carb, my triglycerides have gone up to like 50%. So I'm curious to know if you have any tips, or do you kind of factor in that biomarker as well?
Yeah, absolutely do. So triglycerides, I think for a long time have been discounted a little bit as a valuable biomarker, because it's not particularly informative for estimating atherosclerotic cardiovascular disease risk once we factor in all of the other lipoprotein particle parameters. So I see triglycerides mostly as a metabolic, and specifically not blood glucose, but I would say it's very much a metabolic indicator. Mm-hmm. And I'm saying this because usually when we have an increase in ectopic fat, and specifically liver fat, that's when we tend to see an increase in our fasting triglycerides. And the background here is that whenever there's any factor that leads to fat accumulating in the liver, and there can be a few, and so suddenly the liver, which is supposed to have zero fat, right? Suddenly the liver has these droplets of triglycerides, right? That's a storage form of fat in liver. The liver wants to get rid of them. The liver can try to burn the fat, right? But it has to be able to do something with the energy that comes from burning that fat. So that's limited. And so then it tries to package the triglycerides in these lipoprotein particles, the VLDL, very low density lipoprotein particles. And they're very, very large and very rich in triglycerides. And they're being secreted into the blood. And so if you have a lot of triglycerides in your fasting blood, that usually is a reflection of your liver having triglycerides in the liver cells and in the liver tissue and trying to get rid of that fat by secreting the triglycerides as VLDL particles. So I see triglycerides as an indicator to a large degree of whether or not we have elevated fat in the liver. And fat in the liver is very common these days. We're thinking about, I don't know exactly the most recent numbers, quarter to a third of adults or so in America, for example, in the US, probably have fatty liver disease, which means triglyceride content in the liver exceeding 5%, where it should be 0. And, in some people, this goes up to 20 or 25%. So this can be very dramatic. And having a lot of fat in liver in and of itself is not a great thing, because it damages the liver tissue if it gets really bad, and is a major risk factor for liver disease. So you can actually get advanced liver disease just because of having this fat accumulation in the liver. But it also is highly relevant, and I argue even relevant in people who have fat in liver at lower than the clinically relevant threshold of 5%. So if you have, say, 3% or 4% fat in your liver, that's probably also not a great thing, right? In medicine, we always work with these thresholds where, personally, we know for sure a liver should be 0% fat. But if someone goes up to 4, a doctor would say, well, everything's fine. Well, it's not everything fine. 4.5, everything's still fine. 5, fatty liver disease, right? I think I understand where this is coming from, but it's a bit of I would encourage the viewers to maybe start thinking about this a little differently for themselves, right? I mean, no one forbids you to see this more as a continuous variable and understand, well, I want my liver fat to be 0. I want my liver fat to be 0, for sure. Mm-hmm. And if I had any kind of assessment of my liver fat and was 4%, I wouldn't rest assured that everything's fine because I don't meet the clinical threshold for fatty liver disease. It's still too much fat in the liver. And specifically, it's bad because fat in the liver at any level causes the liver to be insulin resistant. And as we explained earlier, insulin resistance is a major factor underlying type 2 diabetes and in and of itself a risk factor for chronic disease. So people are always interested in thresholds, by the way. Maybe we should add these here as well. Clinically, a doctor would be alarmed if your triglycerides were elevated above 150 milligrams per deciliter. I would say ideally healthy, like if you're a really healthy person, your triglycerides should probably be about 75 or 80 or lower. If they're higher than that, let's say you're always at 120, 130, right? Again, you're not above some kind of clinical threshold, but you probably have some fat in your liver. And I'd say it's worth working on that, like trying to figure out why that is and getting that into the optimal range is what I would try to do.
Yeah. Okay. So all of this is so complicated, and I think it's why it's so important to have a solid understanding. Also because, general practice doctors are not always going to be paying attention to all this stuff and measuring it. So we really want to be our own advocates for our own health. We talked a little bit about, you mentioned low-grade chronic inflammation. I want to talk just a little bit about how it affects our health and what it is, because we hear this term a lot. It's a buzzword, low-grade inflammation. We even hear this word about inflammatory foods, right? Like, oh, this is inflammatory, or this type, or, there's inflammatory diets. Can you walk us through just at a high level what this is? What is low-grade chronic inflammation, and how should we think of it?
Yeah, this is a potentially really complex topic, but high level maybe first. So when we have an inflammation, what it means is an activation of our immune system, right? So everyone knows if you cut yourself with a dirty kitchen knife, right? Bacteria from the kitchen knife will enter the skin at that point, and cells of your immune system that are sitting in that skin will recognize that there are bacteria entering the body. They basically recognize there are cells that are not you. And they raise the alarm and they emit certain chemicals We call them cytokines or chemokines. So these are just mediators of the inflammation response. They basically travel from this spot, like these chemicals travel from this spot to the blood and attract other immune cells that are circulating in the blood, like white blood cells, right? And these white blood cells, they sense the spots where this is happening because of the concentration of these specific cytokines and chemokines, and they enter the tissue. And they basically actually change their form and they change their gene expression programs. Like you could almost imagine this, like if you're a kid, particularly, it's going to be an exciting thought. You know, a white blood cell circulating in the blood is like a gentle police officer on a bicycle. You know, he's riding through a neighborhood and he's just like smiling at everyone and it's very innocent, having a coffee, waves at people. And the moment basically these white blood cells that are circulating get activated, it's a bit like this police officer becomes this transformer type person, and suddenly he's like this fully armed, you know, with like kind of fighting robot, basically. And this is not an exaggeration, actually. I'd say it's much cooler actually in real life, because these cells that are coming into the tissue, they fully change what they are and what they can do in terms of which genes they have switched on and how they operate. And so suddenly, within just a few minutes to hours, you'll have an increase in a number of immune cells in this tissue where the bacteria entered by many, many fold. And they are now all starting to fight these bacteria by recognizing them, by binding to them, by engulfing them, by destroying them. And so this is a real, actual fight that's happening. It's just we can't see it, right? If we could see it, we'd be just looking at stuff like this all the time. There wouldn't be any need for TV, to be honest. And so the outward signs, though, of this type of fulminant, full-on inflammation would be that maybe there is it's redness, right? There's a lot of blood flow to the area. And that's also a part of this orchestration process of the inflammation process. There is maybe it's itching. Maybe there's this yellow pus coming out, right? This is potentially dead white blood cells that have sacrificed themselves in the fight for you, right? They're basically kamikaze fighters, right? They're killing themselves so that you can survive. And so that's a fulminant, full-on inflammation. Now, imagine there are situations where our immune system gets activated, but the degree to which it's activated is less severe, right? So to stick with the police officer who's riding through a neighborhood, he's not like transforming into this fighting machine. He's just maybe, I'm not sure. He's pulling out like a little stick, like, like he's getting a little armed, right? That also happens in the body, and it happens actually fairly regularly. So my lab at Fred Hutch Cancer Center actually studied a process like this in fat tissue, where the body's fat cells uses immune cells in kind of a smart way to regulate how much fat can go in and out of the fat cells. And when the fat cells get too big and they're overwhelmed and cannot store fat anymore, they actually, in a similar way, call immune cells for their help and slightly activate these immune cells. And these immune cells then make the fat cells insulin resistant, preventing them from growing ever bigger and potentially at some point bursting. So it's a really fascinating process as well. And so it's a very similar inflammation process now, but it's not nearly as strong. Like, even though it may happen all around our body, we're not developing a fever. There's no pus coming out anywhere. There's no redness coming out anywhere. But still, if we use the right tools and get a tissue sample and look for those cytokines and chemokines, these mediators of inflammation, or we directly look at the immune cells, we can see that they're slightly elevated, that they're slightly activated, right? And so what we've learned as one potential cause of low-grade chronic inflammation is that if we have very lean, healthy people who have normal amounts of fat mass, if we take a sample from their fat tissue, they have very low numbers of fat cells in there, of immune cells in there, and the immune cells are not activated. There's no real good evidence of low-grade inflammation. But if we took, say, a group of people that is suffering from obesity, they obviously have, by definition, more fat mass in their body. Now we collect some of that fat mass. Now there's maybe 5 or 10-fold more immune cells in there per, say, gram. And those fat cells are slightly activated, in some people at least. And that is, again, a form of low-grade chronic inflammation that we think is likely very harmful because, first of all, when you think about this cut that we made, it's a very strong inflammation, but it's very limited in terms of the amount of body it affects. And it's very limited in time because at some point, a couple of days later, this will be fine again, right? If you have obesity and you have this type of low-grade inflammation in potentially 30%, 40%, 50% of your body mass, right? Because that can be the percentage of body fat in a person with obesity. Then you may simply have this issue that you are exposed to this low-grade inflammation in a large part of your body and for potentially years to decades, right? And as I've explained, the low-grade inflammation itself is a potential contributor to insulin resistance. So that in and of itself can be a problem. And the reason this comes about, we think, by the way, as a add-on here in fat tissue, is that fat tissue, specifically the subcutaneous fat tissue, only has a limited capacity to store fat. It's slightly different for every person, but basically everyone has a certain amount of fat they can safely store in their subcutaneous fat tissue. We call this the personal fat threshold. And so if you ask your body to store fat up to your personal fat threshold, then basically all of the fat is stored away safely in your subcutaneous fat cells, fat tissues. But if you exceed the personal fat threshold, what that really means is that your subcutaneous fat tissue is full. There's basically a limited number of cells. New cells cannot be generated, fat cells, and the existing fat cells are all very, very large and full. Like they're basically full to the limit. And if they were forced to continue taking up fat cells, they would actually burst, and that would be not such a good thing because you would have all of the cellular contents just lying about in between other cells, right? So that's not a good thing. So you need intact, healthy cells that can function, that can take up the fat and release it again in small portions, right? And function normally as part of normal metabolism, right? And so what we have learned is that once people cross this personal fat threshold, what this means is the fat cells are so big, they can no longer take up more fat. And to prevent more fat coming into them, they recruit these immune cells. And these immune cells then make the fat cells insulin resistant. And when the fat cell is insulin resistant, you can imagine insulin is less able to bind to the fat cell and glucose is less able to go into the fat cell. So that's one way in which the fat cell is basically taking up less fat. Another is that in the period after a meal, insulin actually stops the release of fat from the fat cell, right? Because imagine in a fasting state, just as I've explained earlier, the liver releasing small trickle of glucose into the blood, fat cells release a small trickle of fat into the blood. And so the glucose and the fat are basically our fuel for all of our tissues while we're in the fasting state. Now, insulin usually should stop both of this. But if we make the fat cells insulin resistant, then insulin cannot stop it and the fat cell can keep releasing fat. And actually, if it's too big to bear, right, then it wants to keep releasing fat. So that is actually a very plausible way for the individual fat cell to deal with the problem, right? Imagine you're the big fat cell and you're like, oh my God, there's more fat coming and more fat. And you're like feeling, I cannot take anymore. You'll have to find a way to stop doing this and to basically shed some of the fat that you've been forced to store. And so by calling help from immune cells and becoming insulin resistant, you're getting this type of relief in that now you can no longer effectively take up and store glucose and fat, and you can keep releasing fatty acids. Now, so with that, we've saved the subcutaneous fat cells. They're still big, but they can survive. They're not all bursting. But you can probably all imagine now the downside of this effect, and that is, the glucose that no longer can go into the fat cell has to go elsewhere, and or it stays in blood, in which case we're becoming glucose intolerant. And the fatty acids that can no longer be stored in the subcutaneous fat cells, they have to go elsewhere. And that is usually visceral fat and ectopic fat. So that is one way how fat can end up in the liver. I have a whole series of videos about this, by the way, if anyone's interested in learning more. And so to stick with inflammation, though, you asked about other potential sources of inflammation and specifically related to food. There are, I think, likely any number of ways in which foods that we eat could, in a very similar way, trigger like just a small kind of subclinical low-grade inflammation, simply because foods do have, proteins, for example, that could interact with the immune system. And this is a subject that I've actually learned a lot about since I've left graduate school. Because so in graduate school for nutrition, you learn that when you eat protein, dietary protein, it is digested in the stomach, and the protein loses its three-dimensional structure. And then what enters the duodenum, the first part of the small intestinal tract, is just small polypeptides and amino acids that we can absorb. And they should no longer have this typical three-dimensional structure of an intact protein. Now, since what we've learned is that that's actually not entirely correct, at least not for all proteins. There's wide ranges of proteins, including one whole class of proteins called lectins that very clearly are resistant to digestion. And there's good research on a number of lectins from a variety of plants showing clearly that when we eat foods containing these lectins, the lectins do not get degraded, and we can basically fully detect the lectin protein in its original form in the stool on the other end. There's also evidence of humans having actual antibodies to certain lectins. For example, peanut lectins. There's a nice Lancet paper about this. Most Americans have antibodies circulating against peanut lectin. So in other words, that is certainly one possibility, right? That certain proteins that we get from certain foods could be preserving their three-dimensional structure. And what that then means is immune cells that encounter this protein would recognize, oh, this is not a protein of Mario's or a protein of Ty's, right? And it would potentially attack that protein because it recognizes it as foreign. That's how our immune system works. And so in a way, that could certainly trigger an inflammatory response. And it may not be the kind of inflammation that makes you sweat and fevery, and that is something you can see from the outside, but it could certainly be something that is measurable, right? And
I'm really interested, Mario. Do you know on that issue? Do you know if you're kind of attuned to your body, are there sort of indicators of low-grade chronic inflammation? Is something like your gut doesn't feel good after a meal, you're sluggish? You know how sometimes people, I have a response after I eat certain foods, and part of the reason that I choose to eat healthy, in addition to I want to be healthy and live long, is that I feel better when I eat healthier foods. Is there anything to the sort of sense of how you feel in your body that is related to this sort of low-grade chronic inflammation, or is it usually just undetectable, kind of silent beneath the surface?
I don't think we know for sure. I suspect, though, that if someone has migraines or headaches, as you say, GI issues, just feel tired, those could be potentially signs of something like a low-grade inflammatory response going on. But that's me hypothesizing. I really don't know of any data that would support that, to be honest. So I'm not sure.
Yeah, it's interesting. You could probably go on about this forever, and I think it would be fascinating. For anyone who wants to dig into any of these topics in more detail, go to the Nourished by Science channel, and Mario goes through these topics in a really, really a clear and detailed way. So I think maybe to wrap up sort of the metabolic health discussion, now can we just talk about the sort of diet and lifestyle factors that influence our metabolic health? Like, what is it that we can do? What are the specific things that we could do that don't have really, really bad trade-offs with other aspects of health that will really support our metabolic health, especially around sort of the, insulin resistance, diabetes, those types of things?
Yeah, so I'd say for sure we should start with eating in a way that doesn't put us at risk of chronically overeating and gaining weight. It's probably the most important one. As I've explained before, like every one of us has a personal fat threshold up to which we can safely store fat in our subcutaneous fat depots. What that means is if we, throughout our life, continuously gain weight, at some point, we may cross that personal fat threshold point, and then we start storing fat in our visceral and ectopic depots where it contributes in major ways to insulin resistance, potentially leading also to glucose intolerance. It can lead to lipid disorders like high triglycerides, and also lead to higher LDL cholesterol and lower HDL cholesterol levels, topic we haven't talked much about, but certainly related here as well. It can lead to low-grade inflammation, right, as I've explained. So I'd say for sure, eating in a way that makes it more likely for you to not overeat. And so what does that mean? I think that's a big cause of confusion for many people, right? Most people think it just means that we have to somehow accurately measure how much energy we're expending every day, and then we should count calories and just make sure we never eat more than exactly that. Yeah, that may work in theory, but in practice, I think I'm not a big fan of it because it's really not that easy for us to measure accurately what our energy expenditure is. And ideally to do so all the time because it changes, of course. And then second, I don't know what others, but I personally do enjoy my food and actually want to enjoy my food. And I do not enjoy weighing every morsel and typing it into some software to figure out how many calories I've eaten. So where I come out on this point is that I feel we should very, very heavily prioritize eating in a way that maximizes how satiating our food is per calorie, right? So that we feel satiated, even though we haven't eaten all that many calories. And second, really try to minimize all of the known factors that we know make us overeat. And so maybe let's take a look at some of those factors. So what are some of the factors we know make us overeat? Number one, I'd say, is liquid calories in the form of sugar-sweetened or alcoholic beverages. So we know for sure, I've done a clinical trial on this, many other clinical trials. I'd say the data there are pretty conclusive that if you sit down to eat a meal, let's say an identical meal that you eat 3 nights in a row, and you're always similarly hungry, and say the first night you're only having water with it, right? So you're drinking your water, you're eating a meal. If you were to measure how many calories you eat, let's say you eat 600 calories. Okay, now next night you're having the same meal. You can have seconds, of course, right? So you just eat until you're full. You have now a can of beer, and not sure how many calories actually on a can of beer. I don't drink beer, to be honest. I have celiac disease, so I don't know. Do you know how many calories on a can of beer? Let's just say 200.
A couple hundred, 200 calories maybe.
200 calories. So now what you would think is that if I drink the beer, it's 200 calories. Oh, well, then maybe I should be fine just eating 400 calories of the solid food, right? Because then I get my 600 calories and it's the same as the night before. But the reality is that if you drink the beer, you're still going to eat 600. Based on some research, maybe you're going to eat even more than the 600. You eat 700 plus the 200 calories from the beer. Now you're at 800 to 900 calories from this one meal, and you'll feel just as full. Right? That's the interesting part about all of this. The next night, you're going to do the same thing. You say, maybe beer wasn't so good. You're going to have a Coke or lemonade or something. Again, 200 calories, same story, right? So now with all of these where you have sugar-sweetened beverages, be it an energy drink or any kind of alcoholic beverage or even a fruit juice, right? People think fruit juices are much better. Yeah, maybe fruit juice are a little bit better than, say, soda, but they're still very high in a liquid form of sugar that our body doesn't seem to be able to sense very well. And so I'm not a big fan of drinking any kind of beverage in large amount. To me, if someone enjoys a beer or wine, or even a sugar-sweetened beverage, they should clearly be seen as an occasional treat. That's how we handle it in our family, and what I would strongly suggest if you want to prevent chronically overeating. So limit liquid calories from sugar-sweetened and alcoholic beverages. Second, I fall in this whole spectrum of debate about ultra-processed foods that I currently say try to minimize ultra-processed foods and try to eat as many unprocessed or minimally processed foods as you can. And I know that's a contentious statement. Not sure where you fall, Ty. I'm very curious to hear that. But I know some people would say, there's so many healthy ultra-processed foods, and there's also unhealthy unprocessed foods. Like, that's a bad statement. And yes, of course, it's not perfect. But I'd say for now, at least, we have the way ultra-processed foods are defined, right? It's basically concoctions, industrially designed and manufactured concoctions of ingredients extracted from whole foods. So we're talking starch, high fructose corn syrup, fats and oils, right? Along with a long list of largely unregulated substances that are additives, emulsifiers, taste enhancers, artificial colors, artificial flavors. And there's good evidence to suggest, not just suggest. I mean, we all know. If we go to a grocery in certain countries, in industrialized countries, you know for sure this is going on. Ultra-processed foods being made in a lab with extensive testing on volunteers, designed to exactly in a way that we humans cannot resist them, right? We all know these effects where we have certain foods, and they're not just potato chips and ice cream. They can be any number of breakfast cereals and whatever it is, and fast foods, right? And you have one or you have a few, and you'll just, oh my God, you want more, and you keep eating, even though you know yourself you're not really hungry anymore. And the same would never happen if you had a pork chop and broccoli. Like, at some point, you'd be like, well, I'm done with the pork chop and broccoli, right? But here, there's something. And we know what that something is, right? They've designed the food to be what we call hyperpalatable. And it's not surprising that if we are exposed to a lot of foods that are designed to be hyperpalatable, designed to make us overeat, that we, in fact, overeat. So I personally feel like if you can afford it, and if you have the time and the skill, try to prepare as much of your food as cooked from scratch from unprocessed or minimally processed ingredients. And that may change at some point. So if the food industry accepts their responsibility for the global obesity pandemic to some degree at least, I would, if I worked in the food industry, and said, yes, we will continue making affordable foods that have a long shelf life, that is convenient, but we will orchestrate it, we will engineer it to be less hyperpalatable, and they know for sure what this means, to be less energy dense, right? To be less soft, so it can just almost be swallowed without chewing. So all these attributes are things that make us overeat ultra-processed foods. Then we may well have an assortment of things on grocery store shelves that we can safely buy, that we have to chew because maybe they have some fiber added to them, maybe they're protein rich, maybe they're much less energy dense, and maybe the ratio of fat to carbs to salt that they use is yummy, but it's no longer this outrageously hyperpalatable delicious that we just can't stay away from it, right? I personally think, call me naive, but I think this is possible. We may need some regulations to get there, but until we get there, my number one suggestion is, minimize ultra-processed foods, particularly the ones you yourself realize you can't stay away from, right? I mean, that shouldn't be that hard to concept. Other than that, lower, we know for sure, eating foods with a lower energy density is helpful. Higher protein content, higher fiber content is helpful because these are attributes that make foods more satiating per calorie. So what that means is if you say eat foods that have 12% of the energy as protein, you tend to eat more calories, all other things being equal, than if the food had 24% calories coming from protein. Same for fiber. If you eat foods that have very little fiber, and now you add fiber, say it's a yogurt or some other bread, for example, your calorie intake comes down as your fiber intake goes up. And that also probably has to do with just energy density coming down and the need to chew going up, right? Chewing seems to be a big, important thing. Energy density is how many calories we eat per gram of food. And when you look at most natural foods, whether it's a steak or broccoli or an apple, they tend to be fairly low in their energy density. Even a steak. I mean, steak is, I'm not sure, but it's not super high. But if you compare that to ultra-processed food concoctions, where we mostly have an isolated starch with an isolated sugar with an isolated fat, and that's the main body of what we're actually eating, that can be twice as high in terms of the energy density.
And importantly, a lot of the water content removed.
Has been removed, exactly. Yeah. And then all of
that.
And
the structure of the food completely refined to where it doesn't hold up the same way, right?
Exactly.
Yeah.
Where do you fall on the whole ultra-processed debate?
I generally agree with you. Like in principle and practice, limiting as much as you can, I think, within reason is important. And I think there's all sorts of like fuzziness on the margins. You can say examples of, maybe a unsweetened soy milk that has an emulsifier in it. That's of course much healthier than something like a donut, right? I think one of the main sort of, when we think about foods that the definition doesn't capture, is the refined grains or the refined carbohydrates. I think that's one key limitation, where you could have a fully minimally processed food that's just 100% refined grain and oil, and that's not going to be good for metabolic health, right? I think everyone would agree with that. So I think in general, it's just a very useful. There's this whole aspect of like the industry, like you were saying, it's the using really cheap ingredients with the intention to make profit as the key goal and increasing profit. And so then you just, with that incentive system, we have the result of our food system where basically food companies are trying to get people to eat more and more. You don't want to set down the chip. You don't want to set down the whatever cupcake, the cookie. And it makes sense why we have the problem we have today. So I completely agree with that. I'm also interested to hear from you about sort of like the glycemic index of foods. I know you've made some videos about if you're eating, higher carbohydrate meals, ways to sort of manage your blood glucose and make sure you can regulate that. Do you have any other sort of tips around that we can take away?
Well, I'd say, so aside from not overeating, personally, I think a big other aspect that I think we should then try to fit in, because now recognize now we're probably eating, lower calories than if we were eating just, whatever we want, fast food, ultra processed foods. Well, calorie intake is going to go down, but that also means now it's harder, potentially at least, to fit in all the things we need, right? All the micronutrients, all the fiber, all the protein that we need, because we're eating fewer calories, right? And so I think we should really prioritize micronutrient dense eating is a big thing. And personally, I think a good guidance is to always include a solid serving of a protein-rich food and a fiber-rich food in each meal. That's kind of something I try to do. It has a couple of things. So one is, if you eat carbohydrates with something that has a lot of protein and something that has a lot of fiber, it tends to lower the blood glucose response acutely to that carbohydrate. So it makes it easier, in a way, for your body to regulate blood glucose within this homeostatic range that we were talking about. That is partly because both fiber and protein basically lie in the stomach, and they, protein specifically needs to be digested in the stomach, and they both slow down the digestion of carbohydrates. And protein on top of that, the amino acids in protein also act as a stimulant of insulin release. So that's an additional benefit there. So if you do that, whatever it is, so let's say you like having pasta, well, maybe have a piece of salmon or some chicken or some ground beef with it. And also certainly have a big pile of non-starchy vegetables. Have some broccoli or cauliflower, Brussels sprouts, whatever you like. And you try to do this with every meal. Works for breakfast too, by the way. Then you really have this impact that you make it a lot less likely for your blood sugar to cause trouble, because you really help your body, you make it easier for your body. But then on top of that, if we just look at the nutrients that we find in protein-rich foods, and we look at the nutrients that we find in fiber-rich foods, we realize that there's a nice complementarity there in terms of the micronutrients, right? So there's a lot of micronutrients that we find specifically in plant foods, right? So let's say vitamin C that we find very little of, say, in protein foods, which often tend to be animal foods. And yet, at the same time, we may find zinc and copper and iron in the animal foods and less of that in certain plant foods, at least in less bioavailable form. I'm simplifying here a little bit. Maybe an expert like you in the field like this may feel like, it's too simplified. But
no, you're absolutely right, Mario. You're preaching to the choir, of course, because I think we're fully aligned on this. Like, all of my work that I've done related to micronutrients shows the complementarity of the plant source foods and the animal source foods. It's just a very good match, right? Like, there's all sorts of debates about how much should you have, what's the proportion, and all that, what types. But absolutely, I think you're completely spot on. You want to have those you want to have sort of protein-rich animal source foods with a lot of plant source foods, fiber-rich foods, non-starchy vegetables. How about with the timing? Does it matter if you have the starch kind of first, like if you're having courses for a meal? Do you want to try to have the fiber and the protein-rich foods before or at the same time, or does that not really have any effect?
So from a number of perspectives, I think it can be beneficial to have the fiber-rich and protein-rich foods first, or at least with the starchy food. Like, one thing that's probably not ideal is a practice we see sometimes at restaurants where you start your meal with, say, white bread, like baguette and butter or something, and you start the meal with this, right? Because then you
chips and salsa.
Yeah, something, where basically you're starting with a fairly empty calorie, right? Something that comes with a lot of calories, but very little other things that we need. Very few micronutrients, very little in terms of protein or fiber. And it's delicious, right? I mean, who doesn't like, say, a freshly baked baguette with some, let's say butter? And you'll just keep eating. And then your main meal comes and you're still going to eat that, right? And so that puts you, I think, at a higher risk of potentially gaining weight, overeating. But it also puts you at risk of just having eaten a lot of food. You've basically almost met half your allotment of calories, maybe, if you think about it like that. But you've almost not gotten any of the micronutrients, right? You're still down here. And so you're making it harder for yourself. And for, say, your metabolic control, like your blood sugar, for example, you also, again, make it harder for your body because now suddenly the carbs are all coming in all at once. There's no protein that's first needs to be digested. There's no fiber that slows down the digestion of those proteins, of those carbs. And so that makes your blood sugar regulation a lot more challenging. And if you're at least a little bit glucose intolerant, which many people are, you're going to be more likely to having this type of spike, right? Where your blood sugar goes up, say, to 160, 170, 180, maybe higher. And then it potentially comes down fairly rapidly. And you'll have somewhat of a hypo or like lower blood sugar level. And that can also then again set you up for being hungry fairly soon again after a meal, even though you've eaten fairly regularly.
You want the stable blood sugar and the protein, fiber that can help have more stable blood sugar over time. Exactly. Part of why probably they're satiating, right? I would imagine part of the mechanism is that protein and fiber can help stabilize your blood sugar.
Well, partly that's how in the studies ad libitum calorie intake probably is lower when meals were higher in fiber and protein, right? Because it's likely that if the meals are lower in protein and fiber, the number of factors for sure, there's more chewing, less chewing required, for example, but also it's more likely you'll have this type of blood sugar roller coaster if you're prone to that, if you have some degree of glucose intolerance. And there's some good evidence suggesting that even if our blood sugar dips below what our normal baseline is, like even if it doesn't dip in what really would be considered hypoglycemic territory, which is below 70 milligrams per deciliter, but let's say your average baseline is around 90 and you go up to 180 and then it comes down to 80, that already may be enough to make you a little jittery and potentially a little hungry. And so that's probably something, none of this is a catastrophe. It happens once, right? But we're talking about a lifetime of eating here. And so if you constantly make the same mistake where you're constantly starting your meals with the foods that appeal to you the most, but that are nutritionally the most poor, or you have these foods as a standalone snack throughout the day all the time, those things likely add up and could certainly amount to making it a lot harder for your body to regulate the blood glucose level, but also you just having a consistently higher calorie intake than you need to have.
Yeah, I generally feel if I don't get enough protein in a meal, the meal does not last that long. Like I really can't go for a full, 4 hours between meals if I don't get enough protein. Like it's just really clear to me. And your point about the micronutrients, I think many people think micronutrients aren't a problem. We just gotta make sure we get all the right food groups. But actually, and we don't have time to go in this, maybe on a second version here, there are a lot of nutrient deficiencies, even in high-income countries like the U.S. So we've talked a lot about the diet. Now, what about lifestyle factors like exercise or the amount of muscle mass you have, or moving after a meal, standing versus sitting down? What are these other things that we can do to help regulate our blood sugar and just have general better metabolic health?
Yeah, huge topic. So moving after a meal, maybe to start with that, because that's a fairly simple one. I've explained earlier that if you eat a meal that's high in carbohydrates, your pancreas produces insulin, and the insulin goes to the muscle cells, binds to the insulin receptor, and that then leads to a certain receptor, GLUT4, being located to the cell membrane of the muscle cell, and then the muscle cell can take up glucose from the blood into the muscle cell, right? And that helps lower the blood glucose level. Now, if we exercise, if we start to contract our muscles, even just a little bit, there's studies where people just raise their calves, for example, sitting at a desk, and that's fairly minimum movement. Also, just going on a stroll, like you just amble through your neighborhood, right? Doesn't have to be exercise in terms of really sports. You contract your muscles. That allows your musculature to take up glucose in a way that is independent of insulin. It's through a different receptor, but that then is activated. But that makes sense because your muscles that are exercised, they need energy, and glucose is one of the preferred forms of energy. So then the musculature itself says, okay, I don't want to be reliant on whether or not there's insulin out there. I want to be able to take up the glucose. So specifically if you're insulin resistant, and also if you're glucose intolerant to some degree, it can be very helpful to go for a walk. Just a simple walk, or do some simple exercises, a few squats, or I have a pull-up bar here in my office. So if you can, do a few pull-ups, do a few dips, stuff like that. Incorporate it into the day, and potentially even right after the meal, if that works for you, can very, very substantially lower your blood glucose response. If you wear a CGM, give it a try, and it'll be a great motivator actually to do this regularly, because the effect can be huge. Like you could
see it.
Yeah, you could really see the impact.
So just on that, what about exercise before a meal, right? Let's say you do some strength training, even if it's just a little bit. Does that have any effect on your blood sugar after the meal?
It does, but less so than if we did the same exercise after the meal. So it definitely is something I wouldn't want to discourage. And for some people, this works better because, if you do a heavy load exercise, you don't want to have your stomach full. So definitely something that's absolutely fine to do. But if we just look at that one meal, the acute impact on the blood glucose response is a little less substantial than if we did the same exercise after the meal. And that makes sense, right? Because right.
But if you're wanting to sort of take advantage of sort of muscle growth and all of that, you could do some resistance training before a meal. Afterwards, you go on a walk. You get the best of both. Of course, not everyone has time for that, but that is one option, right?
Yeah, and as you said earlier, we don't want to have an anemic view just on blood glucose regulation, right? So with that, maybe let's talk about other forms of exercise. So one thing I think everyone agrees now is extremely important for long-term health is engaging in some form of resistance training regularly. That could be just body weight trainings. So particularly if your viewers, if you're older, if you've never done any kind of weightlifting, no need to join a gym and lift these heavy dumbbells. You can start with, a push-up against the wall, whatever you can do, like a body weight squat. Getting up and down from a chair can be very helpful. So as you've said very nicely earlier, we don't want to be anemic and just look at our blood glucose response, because there's so much more to health. what we really want to consider here is the bigger picture. And if we do that, it's very clear, and everyone agrees on this, I think, across disciplines, that one form of physical activity we should all be engaging if we value our health is some form of resistance training regularly. That can be, lifting weights at the gym, but it can also be any number of just body weight exercises at home, as long as you do them with sufficient intensity. Where ideally you get to the point where your muscle is at least a little bit tired, maybe close to actually where you cannot do the movement anymore cleanly. And you do few repetitions, and you do this maybe at least twice a week. That's because preserving our muscle tissue, for example, if we just look at blood sugar again, is such an important consideration, because about 70 to 80% of the glucose after a meal is being taken up into muscle tissue. So if you now imagine, an 80-year-old lady that's very underweight and has sarcopenia, where there's very little muscle mass, there's just too little muscle tissue there for all the glucose she may be eating. Now, even if she eats small portions and has a small amount of calorie intake, but there's just very little muscle there to take up the glucose. And so having such low muscle mass in and of itself can be a major contributor to glucose intolerance in someone like that. And of course, that's not even the most important consideration, right? Because if you're at that stage, your ability to even function in life, carry your groceries and go down the stairs without falling is really impaired. So what we really all should have in mind is throughout our life that we should always engage in some form of resistance training. And that can be, just something you do you get up from your desk maybe once a day or twice a day, which also helps because you're not sitting for hours at a time. And you just do, 2 sets of 10 bodyweight squats and maybe a push-up, 10 push-ups or something, whatever you can do, right? If it's 3 push-ups, start with that, right? Something small. Yeah. Get moving a little bit and do that in addition to maybe 2 formal sessions of some form of resistance training, I think can be a really good thing to get into. And I would actually add that this is particularly important in the context of people who are on any kind of weight loss program, whether that's a dietary weight loss program or a medication-induced weight loss program or bariatric surgery. Because what we see is whenever we lose weight, about 40 or so % of the weight we lose tends to be lean mass. And most of that is muscle mass. And so when you think about this, of course, if our body is lighter, we also need a little less muscle to carry that lighter body around. But at the same time, if we were able to lose the weight that we want to lose, which is mostly body fat and particularly the visceral and ectopic fat, and hang on to as much of the muscle mass as we can, from a metabolic point of view, from a functional point of view, that would really be ideal. And so there's good evidence to show that if we combine a weight loss effort with a systematic resistance training program, we can maximize the body fat loss and minimize the lean mass, so the muscle loss. And that's certainly something I think I wish more people would give some consideration to before they start a weight loss program.
What about the difference just simply from sitting versus standing? Because I have a standing desk. I try to stand most of the day. And I'm wondering, I don't know the data on this, but I have seen some studies of I think it was something about a bus driver or something versus the train cart driver who's standing. And of course, they're going up and down stairs as well. But does just standing have an influence on blood sugar? Or does that make a difference?
I actually haven't reviewed those data specifically for blood sugar, so I don't know, to be honest. But I would think that varying our positioning and having as much movement throughout the day as possible is really important. So however you achieve that, but we clearly have data that suggests that uninterrupted sitting for extended periods of time in and of itself is damaging, even if in between you actually engage in physical activity. So if having a standing desk helps you to just change your position, and if you stand, you have to shift your weight a little bit more, maybe, your body certainly carries the weight.
I'm almost always on one foot with one foot on a chair doing some sort of rocking motion. Because if I stand still my feet directly beneath me, I get uncomfortable after like 2 minutes, like they're usually just because of gravity, right? So I'm usually leaning in some way or another.
Yeah, so I suspect it does have a difference. That does make an effect. But what I think we can say for sure makes a difference is if you limit uninterrupted periods of sitting as often as you can. So whether that is at a desk, if you just, maybe mentally, if the viewer wants to do this, take a piece of paper and just write down how many hours do you sit at work? How many hours do you sit commuting? How many hours eating? How many hours in recreational activities, right? Maybe you're playing video games, board games, you're watching TV, you're going to the movie theater. Just add these all up and just really become mindful of how many hours you sit. And so in addition to exercise, like where you really go somewhere or you do some specific half an hour, 20 minutes of a program, try to maybe, go for little walks, break it up a little bit. So that's why what I do is I go for a walk almost always twice a day. And partly for that reason, I got this pull-up bar here where I can do dips and pull-ups and do some squats. And so if I do that twice a day, it just breaks up my day. It helps me just, I do some stretching. It actually doesn't take all that much time, but I do think it does make a substantial difference in a number of ways.
Yeah, I try to take work meetings walking when I can. And then I also listen to a lot of audio content. So either a podcast or an audiobook. So I can be either walking somewhere or doing chores, doing dishes or something in the house. And I find that really helps for me. And I also have the sort of, I'll do a few pull-ups, some push-ups. Maybe I have a little hex bar for deadlift. It only takes 2 minutes, but it does help break it up. I'm feeling, we've been sitting for 2 hours and I don't sit for work usually. Like I'm already feeling pretty antsy. My sit bones are kind of sore. And so I can tell like it's not good probably to sit for these extended periods of time.
Yeah,
so,
same here.
Yeah. So what about, before we wrap up, because I know we're almost out of time here, but what about the whole we talked about strength training. What about cardio exercise, things like running?
Yeah, I should disclose I'm not an exercise physiologist. Like my expertise certainly is, not nearly as deep on that front as on nutrition. So this is mostly me reading the literature and partly listening to podcasts and educating myself. So that's the disclaimer there. But I would say, most experts that I've seen, and science would support that, is really that we should pay attention to 3 things: resistance training regularly, some kind of cardio, which is like a lower intensity kind of endurance, can be a brisk walk, can be a jog, can be a rowing machine, a cross trainer, a bike, swimming, whatever it is, something that gets your heart rate up, and doing that consistently. And then minimizing sedentary times. And so I think if people try to it's not easy, right? People are busy. If you work full time and you want to also cook from scratch, as we've said, and you have a family maybe, and maybe even have friends and hobbies, like it's actually a challenge, right? So I think everyone who hears us and says, these guys, they're talking like it's easy. No, I'm not sure about you, Ty, but it's hard for me. Like it's actually an effort regularly.
It's hard.
And, you have to make an effort. And I would encourage everyone to just, we're just sharing what the science clearly shows is the ideal that we maybe want to strive for, right?
Work towards, yeah. And I think it's sort of, if you can, as much as you can integrate things into your lifestyle, like you talked about friends and hobbies, like one thing you can do with a friend is go on a walk to talk about things instead of sitting on the couch. You can play a sport as your hobby. I play sand volleyball and it's fun. Like I don't have to force myself to go because it's a engaging kind of fun social experience. So I fully agree with that, Mario. Look, we're out of time. I really appreciate how much of the time you've spent here with me. And I mean, we haven't even gotten into cardiovascular diseases. We haven't gotten into the healthy body weight and composition, micronutrients. So we got to do a part 2. If you're up for it, maybe we can schedule you back.
Happy to do it.
That would be awesome. Well, thank you, Dr. Mario Kratz. Really been a pleasure. Thanks for joining me.
Thank you so much, Ty. Yeah, same. Pleasure was all mine.